Hello and welcome to the last webinar of this year of 2025. My name is Adrian Fiege and we are here in Karlsruhe. And today here with me is...
Yeah, my name is Kai Behrens and I'm also happy to be here with you, talk about XRF.
Yes, so our topic today is making XRF easy with smarter tools and allowing industry and development to obtain better results even easier than before. Just a few words about the outline, so what to expect. So we will start as usual with a little bit of an introduction. Then we come to how to set up calibration, a little bit the workflow in our new software. We provide some real examples of our new features, so how you can benefit of our new features, how they improve the result quality and the time to result. Then we'll tune to the lab where we will show the SA Tiger Series 3 in action and also some examples more focused around standardless analysis. And we will recap that also a bit then in the studio with some examples again for standardless analysis before we come to the Q&A session where we'll answer your questions. Just briefly, these are our speakers. So Kai Behrens and myself, you already see. And later on, we'll tune to the lab for Renata Janic from our application team. So Kai, maybe you can kick it off.
Yeah, means actually when we get a new instrument into the lab or we need to set up a new application, what we figure out always, hey, when we ask, why are you using the settings? Means people are, oh, yes, we did it always this way. Or, yeah, why did you select this crystal? Oh, yes, somebody selected this crystal. Or yeah, you ask about the settings for detector and oops, there's a PHA setting for majors available. By the way, what does mean PHA? And so we figured out it's pretty complicated sometimes when you need to calibrate a system which has arrived new in the lab. And so now imagine there is new technology around where you simply cannot do the traditional way. And we would like to show you some features and how to use it. Means we just introduced the new SA Tiger Series 3 and we invested a lot in development. So it's 3 and 4 kilowatt excitation power with up to 170 milliamps. For the very light elements, this is extremely nice. We have application-specific analyzer crystals, and yeah, you can do all applications with the standard crystals, but if you want to advance and get better data, more precision, then of course those advanced analyzer optics makes totally sense. And when it comes to detection, there is really a new deal in the block. We have come up with new detectors and new signal processing. But also when working with the instrument, efficiency is something. Means we are putting a lot of emphasis and to make starting samples and getting data much more efficient. And then, of course, maximum instrument uptimes. And there are a lot of tools available to help you there. And so let's dive into those new features to figure out how they will help you on everyday application. One of the things what you would recognize when looking for a new instrument, you would see there is new software around. And also here, of course, we start with a calibration program, it's Calibration Wizard. And this has already integrated, we call it analytical intelligence. And so whenever you are providing some information about your application, this information is processed to provide you with the proposed best optimal measurement conditions. Of course, you always can jump into the data you have received out of the measurement and do an interactive evaluation. So you are able to enhance the data and evaluate if everything makes sense. And of course, last but not least, you are reporting those results, a single result, or you are summarize a bunch of samples. And to monitor the instrument operation, the instrument conditions, we also provide tools. And within those software packages means actually there are functionalities we have invented new. This is so-called, for example, sensor boost, and it actually does what it means. It boosts up the linear count rate of the flow counter or proportional counters. And then we thought, hey, what you can do a lot with fundamental parameters for concentration evaluations, but actually, is there anything more? And we come up with automatic theoretical background calculations, which helps especially reducing measurement times. And putting this everything together and provide those tools also within standardless software actually, yeah, helps you in a lot of cases where you don't have any routine application available.
Mm-hmm. So let's have a little bit of a closer look into the software then.
Yeah, means first when you set up an application, you would see this tree actually. And it first starts that you are adding the information about the calibration samples. So actually you are adding elements, you are adding the concentration table, you are adding the preparation you are proposing. And this information is actually taken into account when proposing measurement conditions. So of course we know when you're having standards around 100 to 1000 ppm, it's actually a trace calibration. If you are going from 100 ppm to 100%, actually you are doing a wide range calibration. And if you provide this data, actually it helps us to propose, yeah, a pretty good measurement method for your samples.
Yeah, so basically up to here it's very straightforward, and the first proposition then comes from the software. Yeah.
Yeah, as I said, means in the moment you are providing standards with the information about elements and concentration, we actually know immediately, hey, you are going to the major element range, you are going to the trace range. And this has implications, means if you analyze major elements, you would have some peaks, SK peaks in the pulsate distribution of the detector. So either we can go to reduce power with traditional instruments, or we use the high count rate detectors with the Series 3. Or if you go for traces, you actually can go to maximum intensity settings. But also we know about typical element interferences. Could be line overlaps or could be matrix interference. So, and our software actually take this into account to propose you pretty good measurement conditions. And the second step actually is where you need to do maintenance for the application. Means one time you have set up a calibration, running drift correction samples, it helps you to maintain this calibration over centuries, basically. And especially in industry, you can implement quality control samples. So actually you can run those samples, and in the moment they are out of the control range, actually they can trigger the drift correction to be run and rerun the quality samples afterwards. So this actually helps you to prepare the setup for your audits, for example. And this is actually in the very beginning. This is a good time to think about the drift correction, to think about the quality check routine. And last but not least, also you are providing information about the preparation parameters. Means we know few speeds, for example, they are ideal for major elements, minor elements. The dilution helps here to reduce the matrix influences. But of course, you're also diluting the traces. So therefore, sometimes pressed pellets is recommended. Sometimes even we need quick results. So they provide a pretty good data for fast process control. But also we can go into loose powder or liquids. They are the quickest way to prepare a sample. And actually it's little sample preparation. And sometimes when we think about metal powder for batteries, they could really help.
Yeah, there are many applications where you can do this actually.
Yeah, so of course, when we now jump into the measurement of samples, one of the things is we are running, or we recommend to run those standards with a proposed measurement condition as scan. And this actually helps you to decide, okay, the scan, the measurement is good enough, or you can jump into it and refine it by yourself. But the first proposal given by the software is actually already pretty good.
Yeah, and then you optimize it, for example, to see whether you can save some time, or here and there actually use certain features, which we'll talk about today.
Yeah, I mean, so and then actually we go and have the data available, and we see on the one hand we see the calibration curve, so you can check calibration curve, and just one element after the other. Here we show iron in silica sand. It is always good in our software that we show at the same time the setup scans. So actually you see immediately what is the impact. And this is actually the first point where you can decide, okay, I would require a background position, and actually I can take a fixed position, I take none, or I take the theoretical one. And the good thing on the theoretical background position, actually it doesn't require any additional measurement. And then, of course, just for judgment reasons, you get the calibration details like offset or calibration slope shown here.
Yeah, so now we've seen a little bit about the software, Kai, and I guess our audience has get a little bit of a grip of how to use it. But we have also certain features that once the solution is set up, so once the calibration is running, that really help you to streamline your process to ensure that you don't have any issues when running it in routine operation, also from a remote place. And one of these is our all-new grabber. So later on you will see it in the lab. So here that's our grabber with an AI functionality which recognizes the sample, even chooses the right mask, for example, and makes sure that we don't analyze, for example, under false conditions. So maybe a volatile liquid under vacuum, that would be sort of a disaster for the instrument. So there's really a fail-safe environment to ensure that you always have smooth processes, even avoid any failures that could be operator-driven, and get the results immediately. But in some cases, you know, especially in production environments, you might be in a situation where you load some samples. Later on, you have to optimize it, or even have you have to run them later, maybe manually, and even there may be a distance between your lab and your desk where you want to start samples and so on. And then we have also a very nice feature. So here you can see on the left-hand side our loader, where you can also define, that's by the color code, different areas. So some areas are maybe just for liquid samples, then others for powders, and it would also prevent the measurement of the false sample here. So the camera can detect what sample type it is. And here you see an image taken from the camera from a sample. It provides an image, so you can judge yourself, but it also identifies it itself. And this is also possible by simply picking a position and then clicking here on this identify sample. So when you are sitting somewhere else, you can simply check, oh, is the sample still loaded? Is there something else? And easily make an adjustment or avoid a false interpretation. It could be also the same way around. You see suddenly a red flag in your results and you wonder why that happened. Well, maybe it's the case like here on Kai's side. Well, you were actually checking a pressed pellet, but then you see when you take the picture, well, this was a metal sample, so obviously something went wrong. Or you had some other sample issue and you see actually it's empty, somebody removed the sample. So this can be really useful in your daily operation to ensure that you do everything right. And the grabber really helps here, which also can handle all samples, even bare samples, without changing tools, for example.
Means actually what I like on this feature, the grabber has a camera inside, and this works simply like your eye. Yeah. Means all the information when we see a sample in a magazine, we actually process a lot of those things, like the size, like the type of sample, like a QR code with a label. And actually the same is now possible with the camera AI.
Exactly. But we also have more, and those who have joined maybe our more recent webinars throughout the year when we launched the SA Tiger, there you can also find more information about this. So with the SA Tiger and the next version of the SPECTRA.ELMENTS software, we also added LabScape Cloud. So LabScape Cloud really monitors all instrument parameters You can see it here, checks what are the maintenance intervals, for example. If everything is green, you're in good shape. We also added certain functionalities which allow you to do some things yourself, like you can see on Kai's side here, for example, replacing the resin cartridge there on the back side yourself. And this is all even supported by augmented reality tools where our service engineers can really guide you to make smaller changes or adjustments if needed. So this helps us to do actual predictive maintenance if needed and improve and boost your system uptime and availability, saving you time and money. With this introduction about the software and our new functionalities, we now want to switch to some use cases, so application examples where we actually apply some of the functionalities to applications. And the first one, Kai, maybe you can talk about is sensor boost.
Yeah, means one of the current limitation in traditional wavelength dispersive instrument is actually the detection. So when we look at both like the scintillation counter or the proportional counters which are available, actually we see that they are pretty good at the very low concentrations and the minor elements, but actually they fail for major concentrations. And often, for example, cement, when we talk about 40% calcium oxide, or when we talk in iron ore about 65% iron oxide, actually they are saturated. So we reduce power, so actually we limit ourselves. And the reason is, in the moment we are having high intensity, actually the detector runs into dead time. It creates a lot of artifacts, like some peaks and escape peaks. And so actually we have analyzed the situation, and our software development team come up with a patented signal processing. We call it sensor boost. So first of all, it stabilizes the peak maximum position. So this actually gets you around all the high voltage alignment for the detector. Then actually it reduces the background noise which is coming into the detector. This is especially important when you have interferences with other elements of high intensity at this moment. And then it eliminates those artifacts. And so the result is pretty astonishing. It's basically doubles the effective linear range easily. So now we are going to something conservatively, something like 4 or 5 million, sometimes even 6 million counts per second, where typical detectors work with 400K, and then with dead time correction, they go up to 1.5 something. And this actually helps to make setup of calibrations very easy, and it helps to speed up the entire instrument because we can measure at high intensities.
Yeah. Now let's take a look how this patented feature results in actual performance here.
Yeah. So actually here we see the signal. It's sodium K alpha. The sensor boost is deactivated. We have here a calibration range up to 8%. So what you would typically do, you would run those standard samples in a scan mode. You would then actually look at the PHA analyze. You would set the upper and the lower limit, and actually that's it. And then you're ending up at a specific linearity, right? Here actually we would switch to sensor boost, and actually we would align at the peak maximum of the pulse height distribution and actually reduce background and the artifacts. And when we look here, means the pattern of the standards at the low ppm range enhances, so the scattering is reduced. And this is simply because of the lower spectral background noise. And actually we see that also the higher range lines up pretty nicely. And we see that the calibration regression actually enhances from 0.91 to 0.97, which is pretty close to the perfect one which we are trying to achieve here.
Yeah, and for those familiar with correlation factors, especially for broad calibrations, and this is for refractory materials here, so this can be relatively challenging. they know that this is a huge improvement in terms, and this, to be honest, simply by clicking a button in the software.
Yeah. So the second thing is what we see in a lot of cases, that the setup of a background position actually is not easy. I mean, sometimes the background is flat, so simply we need one position. Sometimes it's structured, especially for the high energy range where we have the tube lines, or when we have neighboring strong lines. Actually, then we sometimes need 2 or 3 positions, and these cost a lot of measurement time because the intensity is low. It's a background, right? We thought, hey, let's sit down and see what can be done. And of course, it's obviously with a fundamental parameter and understanding the impact and the physics of an instrument, actually, we can come up with theoretical backgrounds. And let's see how they are working. Means during the method development, when we set up a calibration, actually you calculate, or the software calculates the theoretical scattered intensity for each standard. And then we find a common scaling factor. So that's the mathematic. Mm-hmm. So now when we have an unknown sample, we actually do the same thing. Means we have an iteration process. And actually then for the current iteration, we calculate the scattered intensity and actually then find the common scaling factor. And this is actually what we subtract from the analytes. And yeah, so let's have a quick look. So here we have sensor boost, means without background. Inactive, it's 0.994. Actually, in the moment we activate sensor boost, we come to this 0.98. When we add the theoretical backgrounds, we enhance further. And at the very end, the sensor boost and the theoretical backgrounds, we actually are pretty close to the one. Slightly less than just the theoretical background. But the reason is, or the benefit is here, that we have shorter measurement times because we don't need to analyze the backgrounds any longer.
Yeah, so overall we improve our result quality by having a much better, much more robust correlating calibration, especially for the low end. But we also shorten the time, and both with functionalities that is completely implemented in the software.
Yeah. And then this is, from my point of view, that's really impressive because this hasn't been done in XRF over the last decade. And this is a completely new approach and helps really to enhance the signal processing. I would say this is something like going from the small television, and now we are entering 4K, right?
Right, yeah. So maybe another example here, Kai. Maybe you can look into copper ores and what we can do here, for example, with theoretical backgrounds.
Yeah, means actually copper ore. We look for grade control. The copper is interesting. Sometimes there are other majors like nickel, which are easily coming up to 10%. And then sometimes other valuable miners. We can think about lead whenever we go into the battery market. And then, of course, there are penalty elements, typically hazardous elements like arsenic or elements which are hurting us in the mineral processing. And of course, then sometimes matrix gang materials are important. And of course, when we look at the mining operation, a central lab in a mineral processing plant, we have tons of samples. And so typically we go for peak times, they are depending on counting statistics. Mm-hmm. This is an advice, means actually you would need to define, okay, that's the precision I'm looking for. And then you run a sample, look at the intensity, and then you easily can judge, okay, that's the maximum precision I can achieve with this counting time. The problem is with the majors, it's much more easy because we don't need any background settings, so we can just go to the maximum. the background lines, they are costing us a lot of time because intensity is low and we want to achieve a certain counting statistics. So easily they are adding up to something like 10 to 60 seconds or 30 seconds per line. So here we now have a comparison, means actually we measured the background positions, and you can compare actually with the calculated theoretical background. And you see that we almost achieved the same relative standard deviation. So that's quite impressive, what we see here. But the outcome is that actually we can save 3.5 minutes per sample. So that's substantially. And this, on the one hand, helps to feedback the data to the processing people, but also it helps you to increase the utilization of the instrument, the productivity. So actually this means, typically we save here something like easily 40–50% measurement time in this example, just by going to theoretical backgrounds. So now actually there is another deal which is coming up now in recent instrumentation, is that we know multi-channel instruments are quite popular in the former times. They are limited in flexibility. And so now a couple of instruments are available on the market where we actually can combine the measurement sequentially in a goniometer with the measurement parallelly with a multi-element channel, which is an energy dispersive detector. And there are actually two developments within the detector which are making this useful. The one thing is the resolution, and the resolution especially for electrical Peltier-cooled detectors. So actually we are now not that bad compared to former times. And the high count rate capability, we talked about this. Means for us in wavelength dispersive, for us it's always easy. We said with the Series 3 we can go up to 15 million counts per second. For one single element, for energy dispersive detector it was 200K for the entire spectrum. Now with our latest generation, actually we are ending up at 2.4 million counts per second, which is a factor of more than 10 compared to previous generation. And actually, while we are scanning and analyzing the elements with the sequential goniometer, we can measure the spectrum with the same excitation conditions and get a very nice energy dispersive spectrum. And when we are now combining both in a clever way, there is an additional time saving possible. And one of the examples where we have collected some data is actually superalloys. In superalloys, like here, it's a nickel alloy, and we have set up a method which analyzes 7.5 minutes total measurement time. And here you see molybdenum K alpha, fixed position, theoretical background. So we are already pretty fast here. When we are switching now the lower priority elements, which are not so important and can accept a little bit more deviation, we are reducing to 4 minutes total time of result. And actually what it does, and this is the chromium K alpha calibration with a wavelength dispersive measurement. You see the correlation coefficient is 0.999. So perfect. This is what we expect for metal calibration. But when we look at the MEC, the energy dispersive channel, it's almost the same figure. So therefore, in terms of accuracy, it's the same status. And this is also a functionality which I like. It's the backup, right? Means at the same time we have a WD signal and a WD result, we also have backup results by the MEC. And when we look to the data, you would see, hey, we reduced from 7 minutes, 23 seconds down to below 4 minutes per sample and deliver the same quality of data. accepting for some elements a slightly higher relative standard deviation, but still pretty good. Means we are switching here from 0.1% relative standard deviation to 0.2 or below 0.2, which is nothing, right? Yeah. So yeah, it's really a good way to enhance the productivity of an instrument using latest software, using new functionality and new hardware, which helps it to be more, more flexible. But also, just to remember, just to remind you, it also is making the setup of calibration much easier.
Yeah. So Kai, we've learned sensor boost, we've learned theoretical backgrounds, both helping us with time, especially also with improving data quality correlation. Here we've seen now with the multi-channel element channel that we can, for specific applications, really boost the throughput even more by simply putting some elements that maybe not of highest importance to the energy dispersive channel. And so this helps us reducing the time substantially. In this example here, as you can see, highlighted in blue, we just moved 4 elements to the energy dispersive channel. Of course, you can also move more or less, and then you will end up somewhere in between. One last thing I also wanted to mention is, well, if you have the energy dispersive channel, so the MEC, well, you always get the full spectra. So if something is odd, if something is weird, that's a little bit the nice thing about the energy dispersive. You will see it in the spectra. You can see later on evaluated. And so this is also for process control quite a nice feature. Yeah, and Kai, with this, I think we can tune over to Renata, who will show us a little bit the SA Tiger and talk about some of the functionalities and some of the features and quality of our new standardless software, SMART-QUANT, for the SA Tiger Series 3. And after that, we see you here back in the studio.
Hello, welcome to our lab session today. Thanks to my colleagues in the studio. My name is Renata Janic. I'm an application scientist here in our Karlsruhe application lab. I'm standing right next to our new SA Tiger Series 3. Let's have a short look on it. So our new SA Tiger Series 3 comes with a completely new loader configuration and how samples are handled. Here, it's very flexible, so the customer can configure different trays, and with a new combined grabber, with a sucker and with a magnetic grabber, you can load any samples from any position in a cup or as a bare sample. So it's very flexible, and especially the integrated AI camera will check if the sample is loaded, if the right cup is used, so especially if you use different cups with different mask sizes. So this makes things much more easier and fail-safe for the user. The system is equipped with a touchscreen, so this is an option. And now I would like to show you a little bit more about the software. So all the new features about the hardware on the new SA Tiger will be introduced later on by my colleagues or will already be shown. So let's have a closer look to the new software, SPECTRA.ELMENTS. Here right now, I'm connected remotely to the system. So I would like to give you first a short overview about the new SPECTRA.ELMENTS software. So the software is operated with the tabs here in the upper part of the software. So the loader, it's the tab loader. As you can see here, it's the same view like on the touchscreen. So if you have both available, it's exactly the same view. It's very intuitive to start a sample, so it's not a lot of training required. It's very easy. You can have different methods displayed here. You just select the method you would like to use. You can type in the sample ID. You can fix or you can manually type in preparation parameters, but you can also customize these columns, the information you would like to add to the loader information. In case of barcodes or QR codes, these are automatically detected by the AI camera, so it's not necessary to scan it again. After a sample is created, you can just move it to a position by the drag and drop, or you can use also these buttons, then automatically the sample is loaded to a selected method. Or even if you have 10 or 20 samples created, then automatically all the samples are filled into the sample position. So it's very easy. I work quite frequently remotely. So if I want to make sure that the sample is still in position where I have it loaded, not that anybody by mistake has picked out the sample. For example, if I want to check if this sample position is still occupied by my sample, you can easily use the AI camera with this detect samples button, and then the camera will make a picture of the sample position which I have selected, and then you can be sure if the sample is still loaded or not. So this is a quite nice function if you're not exactly right next to the instrument. A sample is still running here, so you see it's shown as a busy samples. Samples which are already analyzed are displayed as okay. You can also have some automatic positions which are shown here with this A label. So this means you can, on any area of the loader, you can define automatic positions. So this means you can define which application will be defined on this position. And as soon as a sample is loaded into the position, the camera will recognize that the sample position is occupied and the measurement is automatically started. So this is also a very quite nice function. The sample is finished now, and the results are shown here in this results window. This is now a check sample, which is predefined by us. So this samples use specifications. And as soon as the sample is within the specification, it's shown with green dots. In case the sample is out of specs, it will be shown in red dots, but you can also change the color codes, so it's customizable. After the samples are measured, you can also use the view window to display results. So all the results can be displayed in this Results Manager tab. So if I now switch to the Results Manager tab, so in fact, this is the same view like for the check sample we have shown now on the screen. And you can see here, so sample ID is shown, which application was used, the elements which are analyzed. They are presented here in a percentage. So also as a user, you can define in which order the elements are shown, if they're shown in percentage or in ppm or in any other unit you would like to define. You can also add additional information which are stored in the database, like which user started the measurement. Additional sample preparation information can also be displayed. So for example, here I selected the sample position to show from which position this sample was analyzed. And you can see here the first measurement, it's out of specs, everything is shown red. So this in fact was another sample, and I can also check it here by the sample position that this was run from another sample position. And this view can be customized, so it's not only related to one method, so you can also mix different methods. So it's up to you how you would like to define these windows. Other parts of the software are the calibration part, which is called the wizard. So this part will be explained more detailed by my colleagues in the studio to give you a better overview. All standardless measurements, scans, or re-evaluation are shown here in XRF evaluation. I will show this more detailed now. And then, of course, you have other parts of the software like the tools or the maintenance part, where you can have a clear overview about the hardware of the system, about each component, about the values, and so on. And you have also some database management where you can save databases, where you can upload also older databases which are maybe used as backup. So here you have more parts available to maintain or to use the software. If I want to have a closer look on this measurement or of any other measurement like the standardless method, you can start also the evaluation button from this button here, or you can enter automatically here with this XRF evaluation tab. So this is now the screen where typically the standardless measurements are evaluated, but you can also, of course, analyze or show any other method also used or run by a calibration. So here we have a big window where, first of all, you will get the elements which are analyzed. The results are displayed here. You can display much more information than shown here. You can display net intensities, background intensities, calculated LLDs, drift correction factors, overlapping correction. So here there is a lot of information you can display. On the left side, you will find all sample preparation definitions, like if you have a pressed pellet, if you want to change the mass or the binder, if you have a fuse speed where maybe you have to recalculate another mass which was used or typed in. On all preparation or sample preparation properties. On the right side, we have so-called evaluation options. So you can decide how is the sample evaluated. So we call it models. So here I have SA check. I have another sample which I have run by a standardless software. It's a glass bead, so I will just switch. You see there is a list of samples which I have already measured. So this is now a glass sample which is analyzed by the standardless software. So the standardless software is quite flexible. So we have a pre-default methods. We have a short method if you just want to make a screening of the sample. But if you're also interested to have more traces or better LLDs for traces, then we have another method which is a little bit more extended measurement time, but you're still free to change some measurement parameters. And of course, the standardless software can be used for any modes like vacuum, helium atmospheric mode, and of course for any mask. So if you have different mask size installed in the automatic mask changer, then of course the standardless software is available for different masks too. Here, now we can see for this sample, we have some more sample properties which are given here. You see the model which is used is called oxide. So this means the results are presented as oxides. You can also make changes in the evaluation. So you can set something as a matrix or fixed compound. I will show this in the next few samples. And then you can also exclude some elements. Maybe you have some elements identified as false positive. So here you can do a manual reevaluation. You can use normalization off and on. You can have a threshold, which is defined by different parameters. So here you have a little bit more evaluation options that you can change. If you have a proper model, which can be used for maybe several samples, you can easily create a new model here with a plus button. So then a new model will be saved. So here we have oxides. We also have some other models already predefined, like elements or for organic samples, where a carbon matrix is already selected. So here you can do some optimization on the evaluation of the standardless sample. Of course, the spectra is shown, the peaks are shown. So here I have a sample, like a glass sample with main compounds like silicon, sodium, calcium, magnesia. I do have some traces. If I click, for example, on calcium, there's also the possibility with this button here to have both views, so the quantitative view and the graphical view. In the graphical view, you will see the spectra. Now for calcium, the calcium peak is shown. The software will automatically label the lines which are detected or the elements which are detected. So you see here the calcium K-alpha-1 peak, the calcium K-beta peak. Here we do have barium lines available. Of course, you can zoom in, you can have a closer look. Also, elements which are presented in the sample will be shown. So here we see a nice overlap of potassium and antimony. And you can, of course, zoom out, zoom in. So it's up to you which view you would like to use. If I switch to another element, then the software will automatically now skip to sodium, to magnesia. And again, all elements are shown, which can also have some overlap effects. But in this case, you are free to decide by the periodic system if you want to display all elements automatically, if you want to switch them off, if only some elements are shown. So you as a user, you can decide how the graphical view is displaying the elements. So if I want to unclick or click, so you can easily check. You can also check, for example, here we have some copper L lines. You can easily check, is there really a peak or not? So this is also quite helpful if you really want to identify false positive elements. And then you can just switch or deactivate them out of the evaluation and recalculate your result. Let's have a look on another sample. Here I analyzed a sand sample. This is a standard certified reference material for a sand sample, which is prepared as pressed pellets. So again, all the relevant parameters of the sample preparation are given here, which binder, which mass was used. Here I have an example. I will enlarge it a little bit to see it a little bit better. So I will decide to have this view, make it a little bit better for you. So here I decided to select silicium as a matrix. So typically this is the evaluation which is selected for these kind of quartz samples. So the SCO2 is selected as matrix. You can easily switch between XRF, means then the XRF value is used to calculate silicon, but you can also add fixed values, or you can set it as a matrix. So it's very easy to switch between different evaluation modes. Here in this sample, I know that this sample contains about 5,300 ppm of iron. Iron is also a very important element in these kind of materials because this can also affect the color of the material. So here I get 5,660 ppm by the standardless software. So you see you're already quite close to the real value. And of course, you can also have some traces detected with the method. So this was just the screening method. And so also some elements which are typically not part of the calibration. So here for quartz, I also have a calibration which is used to analyze the elements of interest. But as you can see here, we also do have quite high tungsten in the sample. So this is just a contamination because a tungsten mill was used here. Typically quartz sample have quite high grinding time. So here with the standardless software, you can also check for other elements which are not part of your calibrations, or maybe some contaminants which you would even not expect in the sample. If you have a more complex samples, even with lower traces, so I have another example here. This is a river clay, a soil sample with a lot of traces. So typically here, the users are also interested in heavy elements, in toxic elements like cadmium, arsen, or lead. And also here you see that you can also detect traces up to low ppm range. Yeah? So here we can also detect cadmium, arsen, lead is here. So if I have a closer look on the signal, again, you can switch to the spectral view. So you can have both in the window. So here we have a lot of traces. You can also zoom in to have a closer look. So this is now the lead signal, which is also given here. And you see there is a very good separation. And also with the standardless software, you can also go down to low ppm range. Measurement parameters can also be optimized a little bit more. Measurement time, if required, can also be increased. And here for this sample, I know there is some organic compound, some LOI in the sample. There is also some nitrogen, which is given by the certificate. And here I can also add some fixed values. You can change also the order of the results. I will just sort them by formula. So you see here, carbon is used as a fixed value, which was given from the certificate. The same for nitrogen is also given as a fixed value, and you just type it in fixed and set the value as you know it from the certificate or from another source. So it's also very easy to do some changes. So in fact, this sample uses an oxides model because this is an oxide sample. So the results are calculated as oxides because also the oxygen has to be taken into account for the modeling of the calculation. But quite often the certificates are given in elements, or maybe you have to report the results in elements. So you can easily switch between compounds and elements, and then the software will recalculate the oxides as elements, which is quite nice. And then, of course, you can also display these results in the results view. This is a little bit to give you a short introduction to our standardless software. And as you see, you can have a list of samples here. You can clear the list. You can have a closer look on the results, on the intensities. You can display a lot of information. You will always see the spectra of your samples. You can always make sure that this is really a peak, or maybe this is a false positive element. So therefore, you can do a lot of optimization by re-evaluating the sample, or maybe changing some evaluation options to make the proper fit for your standardless method. That's from my part now about the standardless software. So I hope you get a good impression about our standardless package. And so let's go back to the studio. Thanks a lot.
Hi, welcome back. Thanks, Renata, for the nice show on the software and the SA Tiger Series 3. Actually, there is one nice tool, and that's the standardless analysis in our instrument called SMART-QUANT. And this is an ideal program which works on fundamental parameter, and it can handle a variety of different samples. And this is actually the way to go whenever we don't have any routine application available, no standards. And this is true for raw material identification and verification. And it works from sodium to americium with the SMART-QUANT FP in the ED world, and from fluorine to americium in the wavelength dispersive world, from ppm range up to 100%, and for helium or vacuum mode. And actually it uses the broad band of all instrument features. And Adrian is now jumping into the applications to show us how this works.
Yeah, so one thing that is, of course, all around us is the battery production field. So for the EV vehicles, electric cars, this has become a huge topic also, of course, for us. Here with our portfolio, we are present almost everywhere in the value chain. We've seen some examples for mining, which may be more wavelength dispersive and calibrated solutions, raw materials, but also precursors and cathode active material. Most of these are based on calibrated solutions. You need relatively high precision. You know what you have. It's in a production environment. You're always dealing with the same material. This is quite different when it comes to battery black mass. So the material that's left over after shredding everything, pulling it, separating most of the electrons and surroundings, then you have mostly remaining some carbides, some particles, a little bit residual from the flux, and also of course the cathode active material, which you're mostly interested to recycle, so your cobalt, nickel, manganese. So since this is a quite inhomogeneous material, and you might receive it from different suppliers, there is typically no way around a standardless solution. And this is where our SMART-QUANT FP and WD really excels. So here is an example from our energy dispersive system, the S2 Puma, where we've analyzed different black masses. You can see some pictures there on Kai's side. And most people are interested, of course, if it's an NMC kind of battery in nickel, cobalt, which is kind of the value determining factor, but then also into trace element contaminants, like how much copper is there left, or in this particular example, we were looking for aluminum, even at the trace element level. So this is something which modern instruments with state-of-the-art fundamental parameters concept can do, and can do pretty precisely and easily. When we look into the software, we might not be completely interested always into the concentrations of an element, but we might rather be interested in certain ratios. And there our software provides a very nice functionality. We call it modules, where we can use certain parameters and certain factors to calculate informative values based on the concentrations that we are measuring. So here, for example, we would look into the NMC molar abundance, so nickel, manganese, or cobalt. In other cases, when people, for example, were working in slag, we would calculate the so-called viscosity or basicity value with this functionality. And then it looks like this. Here we can easily, with this function, identify what kind of NMC have we actually recycled here. Was it something that is more rich in nickel, like a 631 kind of cathode active material, or 333, which is more like the older type of material?
Mm-hmm. Yeah. The good thing here is also for the battery, the black mass powder, it's difficult to press, and the quick sample preparation is as a liquid cup. So you just pour the material into a liquid cup. So pretty easy, straightforward sample preparation.
Exactly. And for nickel, cobalt, manganese, and even aluminum, the little foil that you have on bottom doesn't really matter in terms of sensitivity. Another example that I want to bring to you is alternative fuels. Alternative fuels are used frequently in the cement industry. It's actually waste material, different types of waste material, old wood, used oil, plastics that are relatively affordable energy source for the cement industry. But of course, we have to fulfill certain economical value, environmental regulations, and make sure that we are below certain limits. And this is why monitoring our alternative fuels for certain contaminations like lead, for example, is quite important. And this is something that can also be done by XRF. Here we see examples with a relatively high value for tires for lead, for example.
The difficult thing for alternative fuels is that it's not easy to get standard samples. It means for used oil, this is actually possible, but when we think about used old wood, for example, there is no standard CRM available. So how to set up calibrations?
Yeah, and here how to measure this depends a bit on with which kind of solution in XRF depends a bit on your analytical requirements and precisions. Of course, some good, decent results can also be done with SMART-QUANT, but your better option is actually SPECTRA.ELMENTS. I will show you in a few minutes. Here's a sample. That's how it could look like. You have it actually in a liquid cup. Could also be pressed into a pellet that would look like this. You know, we have the ground material, the shredded material, added some binder, and put it into a pressed pellet. Of course, you can imagine you have a much smoother surface here, so you create better interaction of the X-rays with the sample, not so much confusion of the data, I would say. And what we would recommend here with the SA Tiger in particular is our SPECTRA.ELMENTS solution package. So SPECTRA.ELMENTS is a really broad package that allows you to analyze almost from day one, starting to analyze your materials, including also alternative fuels. It's a really broad, universal solution, as you can imagine by the name. It's dedicated also for petrochemicals, covers 32 elements, and has high precision and accuracy. So we have also best detection with our Dura beryllium tube and shortest instrument, highest instrument uptime ensured by that. Yeah.
The interesting thing is actually in here, we have not a user calibration. We don't have the complete solution standardless. It's something in between. So we have calibrated the system, and actually for you, it's standardless. This is the one thing. The second thing, what we recognize here, it's calibrated on liquid samples, on oils, different oils, used oils, new fresh oils. But actually, we can add the sample preparation and use fundamental parameter to switch from liquid cups into loose powder, into a pressed pellet, and actually still deliver excellent result.
Yeah, and this makes it essentially so flexible. So we can cover not only the typical petrochemical materials and analyze norm compliant, but we can also cover all sorts of, let's call it CONH, so organic kind of materials. So it could be also plastic, polymers, waste, alternative fuel. And the power here comes again, like Kai described, from our software. So the combination of fundamental parameters with variable alphas, for example, and also our so-called automatic quantification of very light elements, including oxygen content, which can vary quite a bit. And if not calculated properly or not measured properly, then it would cause an artifact of your other lighter elements and influence those results. Yeah. So here we see just an overview of what SPECTRA.ELMENTS can do. For example, waste oil, determining in the very low ppm range different elements, including copper, for example. And here, bromium, copper, chromium, cadmium in animal waste material, which is also occasionally used as alternative fuel. And with that, I think, Kai, we can summarize today's presentation.
Yeah, so actually we learned today that SPECTRA.ELMENTS actually streamlines the calibration process, and really it helps us to ensure a fail-safe operation. We learned that the sensor boost actually accelerates the signal processing, and reduces therefore measurement time, is helping to make the setup of calibration easier, especially when we talk about wide ranges, right? The theoretical backgrounds are integrated to the software, and this again helps to speed up the wavelength dispersive instrument. This works for a lot of applications. The multi-element channel was the other choice, actually, to run or go from a sequential mode into a so-called hybrid mode, having sequential wavelength dispersive and simultaneous ED measurements. And then we have learned from Adrian that SMART-QUANT actually excels a lot of complicated applications meanwhile, especially when we don't have any standard materials available to set up calibrations. And solutions we are providing, like the PetroQuant, is something in between, still a very flexible tool like the standardless software, and it's standardless for the user. But actually, it really helps to get data as good as a calibration. And then last but not least, especially when it comes to productivity, the LabScape Cloud helps us to have the instrument running operational 24/7 the entire year without any interruption. Yeah.
And with this, we can switch to the Q&A session. Let us just quickly pull up the notes and then we go ahead.
Okay, welcome back to our Q&A session. And Adrian, so we are looking for a few questions.
Yeah, so we've received a couple questions both during the webinar as well as before, and we'll focus on some of them here. So the first one here, we analyze raw materials for cement production with a more general program. How would these functions that you described help us?
Yeah, of course, I could envision that especially the sensor boost is pretty cool for raw mix. We have a lot of different materials like dolomite, limestone, or sand, gypsum with low concentration of sulfur, high concentration of sulfur, or traces of magnesium, then suddenly higher. And here the wide range calibration capabilities of sensor boost are pretty cool to have one common method without specific measurement conditions. Yeah. In addition, typically the theoretical backgrounds would help, I guess, to enhance the accuracy.
Mm-hmm. We have another question here that is for polymers. So we are looking for catalyst residue in polymers. Sometimes we also find impurities coming from process materials. Can we do this with the new standardless program?
Yeah, so I would envision that you have materials for your process or for the catalyst, and then the impurities easily can be done by standardless. Mm-hmm. And then there are different ways. We can analyze by standardless for the entire element range. We can combine the calibration with the standardless lines for the element of interest, or you even can utilize PetroQuant and just change the preparation, as we have seen for the alternative raw materials in cement. You change the preparation and suddenly the values are pretty cool.
Third question here is, we are analyzing various metals. Is it possible to run some test samples on your new device here?
Yeah, it means we have instruments available across the globe in our hubs. So this could be Singapore, Bangalore, Europe, Paris, Karlsruhe, but also Madison or Atibaia in Brazil, Melbourne. So simply contact us and our local sales will help you and provide you data with our application scientists. And then you can go from that for the evaluation of future instruments.
And more a general question about data handling. Can I export my data or send my data to LIMS?
Yeah, so the data out of the reporting software can be copy-paste to any Office application. Also, in the moment you are providing by LIMS system or by barcode or by typing the exact name, actually the result will automatically be transferred to the LIMS system. This is possible, and that's a normal function in automation. Yeah, so we also can hook up the instrument to automated sample preparation.
Okay, thank you, Kai. So we are running a little bit out of time, so maybe 2 more questions here. We are a commercial service lab analyzing different ore and concentrates. Would the MEC, so this multi-channel, help us, for example, for nickel ore?
Yeah, I mean, for a commercial lab, this is really a cool device. And we have seen that we typically can save something in the range of 30–40% measurement times for nickel ores. I can imagine that some of the gangue materials, some of the elements like chromium, the data from the MEC would be good enough and we would save this time. So this means the same instrument can run 30–40% more samples, which pays back easily within a year or 2 in a commercial lab.
So, and last question is a general one. Will we get the recording and the slides? So this is, yeah, you after every our webinars or online seminars, you will get the recording and the slides. They will send to you automatically. And I believe there are also some news on the website.
Yeah, so please just visit Bruker webpage and look for SA Tiger Series 3. There are some new lab reports available. Yeah, and so we are ending 2025. So we are looking here in Karlsruhe for the Christmas markets and enter the hot wine season. Yeah, I'm really looking forward to see you next year, and I wish you all the best for Christmas and New Year's Eve. And I hope to see you soon next year.
Yeah, same from my side. Happy holidays. Good start into 2026. Hope to see you soon, webinars or in person. Have a great day.